Hi, everyone. Thanks for coming to my session, last session of DevOps this year. I'm sadly not as cool as the intro, but I still hope to bring you cool agent stuff. I want to take this session today a bit spontaneous, so feel free to raise your hand. If I don't see you, raise it more. I'm happy to dive into your questions and check some code with you if you want. So today I want to share you a whole bunch of tips and tricks to make this AI application that you may try to build actually work, actually do what you want. And the first thing is this very interesting article where some researchers, it's not a really big scale proper research, but they looked at a couple of products, which AI products go viral and which one flop, basically. And they saw that, of course, the more value you get out of a successful run of this AI app, the more people want to use it, but very importantly also, like the consequence of your errors. If the consequence of errors is high, you can forget it in AI apps because they will make errors, as we all know. And the effort to correct, if you can super easily roll back, people are going to be much more inclined to use this. That's why a program like Cursor, where you can always roll back if it introduced errors, has much more success than, for example, Monday's AI integration, where it just creates you new tickets. And it's a real mess if you actually didn't want them because you cannot just roll back. That's something to keep in mind when you build your AI app. Make it rollbackable. Apart from that, I'm going to share you a bunch of tips and tricks with LangChain4j. Before I do that, I would like to ask, raise your hands, who was not in my keynote? You were all there. Wow. OK, well, then I'm going to skip all those slides that explain what LangChain4j is about, and I hope that these 3 people or so kind of know. Good. So I'm Lisa Raas. I'm a collaborator of the LangChain4j framework since almost at the start. And recently, I also joined Oracle for Java and AI in a more broader sense, including machine learning, including AI-powered applications. So I'm also always very happy to talk to you, or you come complain to me. That's my favorite if you're like missing things in the ecosystem or want to put things on my radar. If you want to contact me, best thing is via LinkedIn. I just accept any invite, and then you can write to me. So these are the slides I'm going to skip because we all saw them. And yes, let's dive right into RAG. Who tried RAG already? So the thing where you try to load documents. OK, that's quite some people, like say 30%. Who was disappointed? Yeah, OK, still also quite some people. So basic RAG is where you want to add relevant info to your user question. This relevant info comes from your company documents or your internal things that the model had not been trained on before. So it managed to answer you without retraining of the model on much broader topics that know about your own company, for example. And then you send that user question and these extra pieces of information from your sources to the model, and it can give an informed answer. The idea is very good, but the way that the basic RAG was hyped and worked, it didn't work all that well. It worked by chunking documents in pieces, then creating vectors so you could find similarly the things that mean something similar than the question, and this is how it was added. But it has a lot of shortcomings, like it doesn't find all the pieces we want. It does find many chunks we didn't want that are also sent to the model. It gets confused and it answers really weird things that have nothing to do with the question anymore, and so on and so on. And that's why I want to show you that there is advanced RAG. It's a bit more complex, but I'm going to explain you all these pieces and why they are important and how they're going to solve many of these problems with the basic RAG. So to start with, what we see on the left is this query transformer. I'm going to show you why you actually need this. If we have time at the end of the session, I'm going to show you an AI drug discovery assistant, pretty complex agentic system. And this is a little output of it. So on the left, you see what's going on in my chat. And on the right, you see what's going on in the logs. I find it interesting to see those two in parallel. And at some point, it asked me, shall we proceed to the next step where we find antibody characteristics and so on? And I say, yes, please. And I see there in the chat coming by a piece that says a juicy stew of personal stories, funny bits of sex and love and friendship. And I'm like, whoa, what was in my documents? Why did it find it here? And then I checked, okay, it was using web search to retrieve extra content, and it searched for yes, please. That was, of course, not what I intended, right? And that's where these query transformers come in. So a compressing query transformer takes in the memory, and instead of just taking yes, please, it's going to rephrase what I actually want to search, which would be find characteristics for this and this antibody. This wouldn't have happened. So I think it's really important in production, right? An expanding query transformer will do something similar, taking in history, and it will transform it into multiple queries that hopefully at least one of them or many of them yield the results that you would want. So definitely use that when you're in the chat and you're going to use RAG. The next part is the query router and the multiple content retrievers. So you don't have to stick to chunked documents. You can use database search. You can use graph RAG. You can use web search, as you saw in the other example. And you can use those in parallel. And you'll need a query router, which is also typically has an LLM, unless you find nice rules to say, OK, when it contains these and these words, send it there. So you can mix and match with LLMs where you want or not. But if you use an LLM, this query router will both decide where to send it and then rewrite a query. Because a SQL query is, of course, very different than something you're going to try on a web search. I want to show you some code for the SQL content retriever, for example. And I will also actually mainly want to point you to where you can find the examples. So you have this LangChain4j examples repository. The link is up there. And if you go there, we have, next to this agentic tutorial that we're going to look at after, we have RAG examples. And we have there folders for easy RAG. Sorry, I cannot zoom on this, but you'll have to believe me and you can try it at home. Easy RAG, naive RAG, advanced RAG. And that's where I want you to look. All these interfaces I've been showing you, and I will show you, they are listed there. So you have query compression, query routing, and so on. And the last one here is the SQL database content retriever. And what you do is you have a database GDBC data source. Hi. And you're gonna add this to your content retriever just like this. This will pass, LangChain4j will take care of giving the schema to the content retriever and say, like, OK, you can query this database, and here's the schema, here are all the tables. And then most models are actually very good at writing human language to SQL when they know the schema. So this works pretty well. It's also pretty dangerous. You will see here on top, never use this in production because you are actually accessing your database, or at least use some serious checks before using this. So these are a couple of different ways to retrieve content, and you can make your own implementation. So all the great things there are interfaces, and if you want to say, oh, I have a specific API, even I have an MCP server there to find context or documentation, you can plug them all in. I worked at a company before, and they did company-wide search over it was called Naboo. They did it over your code base, over all your tickets, over Confluence documents. And that's very interesting. And they did not use much of this RAG. They did actually very smart things like expanding synonyms. So they use LLMs to make more synonyms and just go find those words in the documents, for example. I've heard somebody that pre-processed the documents and said, what questions would be asked about this, probably? And then his RAG worked like, OK, I have a question. I retrieve the similar questions, and I already know to which pieces these questions point, and that's the pieces I'm gonna add. So just be smart about this. Based on your use case, you can do so much more than just chunk and find. Then we get to the content aggregator. Either you take default content aggregator, that just means we just slam all these chunks one after another. But you can also have a yeah, by the way, the green things are the default implementations that you can use out of the box. Important. We have this re-ranking content aggregator that uses a tiny scoring model. It's also AI, but it's not an LLM. And it's extremely good and extremely fast at answering the question, if this is the question, how good does this chunk of information, how relevant is it? And then it gives it a score, and then you can throw out everything that's not relevant, and I can really recommend this, because otherwise your model gets confused by all kind of junk. Say, like, if this web search threw in that answer that I found there, I really want to kick that out before passing all this content onto the model. Last thing is this content injector. This is a bit of a flaw in LangChain4j. I've tried to get this changed, but we then didn't because of backward compatibility. But the current content injector takes a question, says, use all of the following information, and then pastes all the chunks. And the problem with that is that the model will use all of the following information, and that's typically not what you want. So I also would recommend you, if you go to production or you want proper answers out of this, override this standard method with something like, if relevant to the question, you can use the following information. Good. Another tip, the way RAG is currently implemented in LangChain4j is one shot. So you get your memory, your last question, it is transformed into a query or multiple queries, it's retrieved, and that's it. And very often you have questions where you actually, you retrieve chunks, but more questions come up, or oh, you only had half of it and you want to re-query, or you had half of the answer. And now, given that the weather is this, but now we want to actually ask our follow-up question based on that weather. That's why I would say wrap your RAG in a tool annotation. Then for the model, it becomes, here you can search in our internal documents or about the weather or whatever, and the model will call that thing as many times as it wants, and it will just re-query if it finds that it doesn't know enough yet. Then some things also very much for production. Typically, you don't want hallucinations, and you want to be careful with giving LLM answers back. So often you will want to give actual phrases from your documentation back. So you can save resources, like which original file does this come from, in the metadata that is stored in the vector store or anywhere else, so that you can retrieve the original document and, for example, highlight or just give these pieces back and refer to the document. And the other thing is read permissions. So if you build a very big system, not every user is allowed to see every piece of information. Access rights is also something you can put on this metadata, and then when a user queries, you check with his user ID which of the pieces he's actually allowed to see, and you put a hard filter on that. So like a code filter, you don't say to the LLM, please don't tell him about this and this, because that's not going to work. So you filter out these fragments in the hard way. Good. Another thing is tool calling. We had a lot of extensions beyond the basic tool calling. So quick recap. We can expose tools to models, and whenever we send a question, we have all the tools that we make available are sent along, and it's basically saying, like, here are the tools you have, or here are the functions. This is the name, it does this with a description, and here's the input parameters you will need. And then the model will say, maybe I need this now. If somebody asks about the weather, it sees it has a tool to find the weather for a specific city, then it will probably call this with whatever city we're in. And we made like some nice progress, and I'm going to show you that in code. This is currently not in our tutorial repo, but I plan to add that in the coming weeks. So return immediate is a new nice thing that we have. Depending on how you design your systems, you will not be interested in the LLM response, but you'll be directly interested in the tool response, or you will be interested in nothing at all, and you just want to fire the tool. So I build very often systems where I'm just like, okay, my LLM is kind of a dispatcher, and now I wanted to say, update the state in the database. I don't care about the answer, and I don't care about the LLM telling me, oh, the update was successful. I would say, if the update was not successful, I want a hard fail, because it means something is off with my database. And then I don't want this LLM to tell the user that. I want to basically quit the program and log it and inform support. So for those cases, we have return immediate. So in this example, we have tools, which is just for the demo, an add method. And we annotate it with tool, so we can use it. And we say the return behavior immediate. What it's going to do is that after the model plays the tool call, we are not going to call the model back with the answer. So it saves you tokens, it saves you time. And we're going to give a return object that, just return immediate demo, yep, going to give us a return result object here. And we can then get the content out of that. So here I want to show two things at once. I'm commenting this out for now. This is the ones we want to check here. So we're going to ask add 284 and 42 to this AI service that has our tools here. We added it. I'll talk about the other part later. Also interesting, you can say maximal 3 sequential tool invocations. It avoids that the system gets into these loops that sometimes we see in Cursor, etc. Then we call it, we say do this addition, and what we get is this result of string, and we can get the tool executions out of there, get the result object, and since we know it's going to be an int, we can, oh man, I've been forgetting this word all the time. Anyway, cast, thank you. I don't know what it's with cast, I keep forgetting it. So we cast it. Voila, and then it didn't go back to the LLM, and when we run that, you'll see it just gives a kind of deterministic answer. So depending on what you try to do, at least your tool gives you an answer that within ranges of what you know what to expect. It's very different than an LLM answer that still does something with this. That's for this one. Then something else we have is that we can dynamically add tools because say if you use MCP servers, you very, very easily end up with 20, 30 tool descriptions, and they are sent to the model with every request, which consumes a lot of tokens and which also often confuses your model. If there's too many tools, they're going to start trying weird things. So we can filter those down, and that we do as follows. Instead of just adding tools to our AI service, we will add a tool provider. And in this tool provider here, we have basically an if statement in our case. If the user request contains booking, well, then we will add a get booking details tool and a cancel booking tool. And if it's not about bookings, we are not even going to add those. It's pretty verbose, sadly, how you then specifically add them. I hope we can make this a bit less verbose. But just so you know, it's possible to restrict the tools. You can restrict them based on the user ID, if they have tools that should not be executed by certain users, and so on. I'm not going to run the demo, but it basically says if you ask what's the weather like today, and you would look in the logs, no tools are going to be added. But if you ask, can you show me booking this, then you will see these booking tools added. And then a last thing I want to show is that, I love this, it's that we can annotate AI services as tools. So you can use an AI service as just another tool. And so the model that's going to use this tool, which is another AI service, is not going to even know that there is AI involved there. So this one says it answers questions regarding bookings. That's all my invoking AI services will know about it. And then internally, we have that it's an assistant. There's an LLM in there. There's tools in there. And I want to show you that one still. That's this part where we can add that as well. So that's here. We also add this assistant with its dynamically added tools via this booking tool provider that we did before. So we just add this whole AI service as a tool to the new AI service. And if then we're gonna ask cancel booking, this will route it. I can happily run it. So it's not gonna. It also has this add method here, but it also has the booking methods because we have booking in the question. This AI service knows, oh, I have a tool that's going to help me with bookings. It's going to ask the question on, and then the next one should add these booking tools. Yes, so it has been successfully cancelled, and I log these tool calls just to show that they're definitely called. Voila, that's some tool magic, extended use of tools that you can mix and match for your use case. Again, if you have questions, feel free. Otherwise, I think I'm perfectly explaining it. Yeah.
How certain can you be that a tool will be called?
Okay, the question is, how certain can you be that a tool will be called? You can absolutely not. You have to keep that in mind, sadly. But typically, a good model, say this is GPT-4o mini mostly in my demos, will rather call a tool than skip a tool, even if it could do it perfectly by itself. Like addition to a certain degree, it can do it by itself. Still, if it sees a tool, it will typically call it. If you're working with local models that are much smaller, much less smart, there's especially for tool calling, they're not very good. They will either skip it, call it too many times, call it with fake parameters, and then most of them can also only call one tool. Whereas these smarter models, they can call again, call things in parallel. So this is very model dependent. And yeah, as everything with LLMs, it's never 100% sure. All right, MCP servers are also added in LangChain4j about 6 or so months ago, or a bit more. They are all the hype. I like them and I hate them at the same time. And so I will tell you what's good about them, what's bad about them. So before, when you wanted to get information from any service or API, it was, I find, kind of hard. Like you want to get information from your database, you need a runtime that connects to your database, you need to learn SQL. You want to talk to any Google service, you have to get into their things. It's really hard to set up. You want to push to GitHub, you have to know Git, you have to do SSH, and so on, and so on. You need a new syntax and often also a new runtime for all these things. And what MCP did was, hooray, it just takes care of that runtime and care of that syntax for you and makes that an LLM can just get anything done on your database, on your Google Docs, or on your weather API, whatever you have an MCP server for. So the good thing is it became easy. The kind of bad thing is that now we have an LLM in the middle that makes it very non-deterministic. If you want to know some more, this link here, Model Context Protocol /servers, it's from the Anthropic guys, and wanted to just show you for a bit of inspiration. If you go there, ignore the reference servers, ignore archived, go to official integrations for third-party servers, because those are companies that expose their own MCP server, so you can kind of trust it a bit more than when any other software developer says, here's a tool, and you just don't know what's going on in that tool. And so you have a huge list. And let me scroll. We have Elasticsearch in there. I'm just remembering my alphabet order. So yeah, like just to query your data in Elasticsearch, but then from natural language or an AI, an LLM can decide to do it himself based on whatever whatever task you gave it. If it finds it should go query, it will go query. We have GitHub and GitLab in there. It's all very powerful, very interesting, and a bit dangerous. Like I can just say, create me a new repo, and I suppose also delete my repo, and it will just do that. Okay, so be aware. So very importantly, when you deal, oh yeah, this is one I wanted to talk about too, Context 7. It's an extremely popular MCP server that you might want to add to your coding agent. What it does is it gives the most up-to-date documentation about kind of any framework you would want to be using while writing code. Also anything outside of training data. Good, so very cool. You write this, or somebody wrote these access methods once, and everybody can use them forever. And you can access kind of any server by now, any service in natural language. That's the cool part. The less cool part is what is in these MCP servers. So if it's an official integration, you can trust it a bit more. If it's a non-official integration, go through that code, because you're typically exposing keys to your GitHub repo or to your emails or whatever. So it's really tricky. There's so many write and delete functions where often you just want to read. that's a problem. And if you go ask to legal if you can integrate MCP servers in your tech stack, good luck with that, depending on what company you're working for. Something that's really helpful is that in LangChain4j you can filter down what methods you actually expose to your LLM. So this is a GitHub MCP client, and we say we only expose get issues, get issue commands, and list the issues, no deleting or anything else. So know that this is available. You're not obliged to deal with all the delete and create things. Good, then agentic patterns. So since almost everybody was in the keynote, I'm gonna skip this. Just we have these 3 types of agents, the real LLM agents. Then we have just code that we can annotate as agents, and then we can have asking human feedback that we can also annotate as agents so that we can use them all together, all these pieces, in workflows. Sequence, parallel, loop, and conditional are like integrated. Or you have self-orchestration. And to remind you, you can combine, mix and match from both. And any combo, sequence, or parallel, or something is again an agent that you can just use inside another sequence, loop, whatever you want. So this example we've already seen in the keynote. We're going to skip it. So are agents the new hype? Are agents the new very wasteful resource thing that does nothing useful? According to me, not. According to me, agents are a solution for all the problems we faced before, or many of them, because they allow you to decompose things that were too complex for an LLM, not just decompose the tasks and make sure they are executed in the order you want, with checks in the middle to see, okay, is my state actually correct before I even continue? That's things you can do. On top of that, you can limit the tools per task. So you're not having one big service that has access to all the tools and will call them at random moments and be impossibly confused. On top of that, since if you decompose your workflow enough, you get much easier tasks, and sometimes you don't need a full-blown big LLM for it. Some tasks you could train a little model that answers things like, here is what the model proposed, here's what the user answered. Are they actually done, or was the conclusion reached? If yes, you just continue in your workflow. If no, you keep looping here in that conversation. All things like that I think in the end will make it less resource wasteful with very much smaller models and very much more controlled and also testable chunk by chunk, much better than when one big service has to solve all your problems. So if you're trying to design an agentic system, and I would say whatever you design of AI-powered app, consider to make it an agentic system. I want to give you here 13 steps on how to go about that to give you the best chances to not waste your time and to actually end up with a product that works controllably and actually does what the users wanted to do with it. So first step, it's not let's throw AI at everything. It's like go see with the stakeholders what problem are you really trying to solve and how much value will this bring. And will that value justify the effort you're going to spend? Because if you build an agentic system, you're going to typically have much more work than when you just have one big AI model and you say, now do all of these things for me, and here are all my tools, and you're done. But it's just not going to work. It's not going to work controllably, reliably. If you want to set up a proper agentic system, you're going to be designing much more because you're going to be much more in control. So it becomes like writing real software that also really takes time to design, work on, and maintain. Good. So for the example here, like we are going to try to help HR with some hiring process tasks, so they can actually concentrate on keeping the employees happy and engaged instead of making us fill files all the time. So once you know your problem and you're sure you will bring a lot of value if you manage to pull it off, go and look with the stakeholders what the current process is and map that out with them. Not what you think it is, but because they will have to use it in the end. So let's say for this one, they receive a CV. HR does a first scan if this is anything usable? If no, it's rejected. If yes, then the manager has a quick look if this person has actually the skills kind of that are required. If no, reject. If yes, HR is probably going to place that phone call to ask about salary expectations, relocation, whatever. If that fails, reject. If not, we go on to the proper review by the manager and the team, ideally, that will give their end conclusion together to HR, who is gonna either reject or schedule an on-site interview, for example, with the candidates. And that's a back and forth to find the right date, schedule that meeting, and then, voila, you schedule a meeting. So if this is our system that we want to make with AI, we will have to see, okay, which part of these ones we can replace with an agent, or at least have an agent help the humans to do it. And then I really recommend already go check with legal, because there's many, many, many reasons why legal will not want to allow an AI-powered app. For example, Accessibility Act, nice thing with AI is that it makes accessibility actually easier if you design it well. There is GDPR always, like, can we even take this candidate's CV and send it to OpenAI? I bet not. So you will have to need local model to do this, or local models are typically not good enough, so you will need to buy bigger hardware just for this, and run a bigger open source model that can actually handle it. And then probably your CEO is going to say, no, that's not worth it for this use case. These things, I really want you to find it out early. Then there's the EU Artificial Intelligence Act, which will tell you that, scoring applicants for job openings is a high-risk category thing because you're gatekeeping and you risk discrimination. And I think it's righteously in the high-risk category. But if you want to actually use this or use this in production, you will need certifications and give guarantees that you do everything to avoid discrimination there, and so on and so on. It's not fun, and the answer is probably going to be no, you cannot do this, or you have to drill it down seriously. But still, rather find it out early than when you did a lot of work. So when you would have permission to do at least parts of your workflow with AI, you chunk your system, which in this case, the way I've written it out, is actually already chunked. And then we're gonna see where we can add AI in this flow. So first thing would be this first HR scan, like, is this person even living in a territory that we're allowed to hire in? Do they have the required amount of experience, and so on and so on? It can be, according to me, pretty well done by an AI that either does it entirely or informs HR, hey, there's in these and these flags, or like everything is fine. So HR has a little bit less work figuring all that out. Managers can, same thing, like, does this person have the skills for the job? It's also pretty obvious for this first scan. Telephone interview itself, that's of course gonna be still a person. I'm just thinking, like, I would like to see when it becomes AI agents interviewing you. Not looking forward to that. But you can help at least HR flagging, like, oh, these and these and these points are a bit unclear. Definitely clarify that, which saves them, again, time. Then, after the phone interview would pass, the manager and the team review can again be similarly AI assisted, where AI also looks at the job description and the application and say, like, okay, well, this seems to be well covered, but here and here and here, we're not too sure. Just to help this review process to go better. Then, just bundling all the reviews of these people, you can do that with a piece of code. And then HR has to schedule an interview with this candidate, and there you can add this human in the loop system, which I think is very helpful, because otherwise it's like, yeah, you send an email, can you come on this day? No, that doesn't work, and you have to, for HR, that's just a lot of new emails and context switching, whereas that you could definitely, I think, do with agents, but you have to set it up smartly. And then to write a reject email, you could have that done by AI, or at least proposed by AI and sent off by a human. Oh, and I even forgot to say, like, when they are invited, like sending out a calendar invitation and stuff, AI can also do that. Okay, then once you have like an idea where you're going to put AI in all that process, you will have to see, okay, how much latency does it give us? How much is it going to cost us per run? Is this actually feasible? In this case, you're going to say, okay, this process, any step in there anyway takes typically an hour or hours or days. So yes, if AI takes maybe 3 minutes to run through this thing, that's definitely still worth it. If it's other things in chatbots and it takes a minute to get an answer, it's a different question. And that's where you can also check if you can replace things like here, sending out a rejection email. That doesn't have to be AI at all. I would absolutely not have AI do that because you risk liabilities. You can just have a, say that a template and then put in the contacts of the candidate and send the template out instead. Things like that. We try to optimize, try to get the latency down by getting AI out of there, which wherever you can, I would recommend you to do so. Okay, before you want to implement this, first thing would be to build your hardest agent. Yes, I've added that phone there to say like, okay, if after 3 loops or so of back and forth, AI does not manage to get an appointment with this candidate, you escalate to HR, they can call. So let's say the hardest part in here, I would say, is this loop with an AI agent that has access to the calendar of everybody and tries to find a date together with this human via email. So let's build this one. And I have an example here so you can see what this looks like a little bit, although it's absolutely not, I mean, it doesn't have real access to the calendar. I've just written in the prompt which dates are available. That's going to be in our agentic tutorial. So in the examples, you have this agentic tutorial. I've shown parts of this in the keynote already. The one I want to show you today is this human in the loop, 9B one. What it is it's a little chatbot with a memory, because the model has to remember what it has already proposed, what the user, which dates he already could not come to propose a new date. It has memory and it has a goal. Basically, the goal is whenever the user agreed to a date that actually fits for everybody else, then we are done and we exit this loop and we just send confirmation. So it works like this. We add a memory to our meeting proposer part. And also typically then a tool to deal with our agenda. For now, I've just in this proposer's system message written basically every week, every morning of Monday, Tuesday, Thursday or something works. Just keep asking on. Then it's gonna output a proposal. That's then going to be sent to the human in the loop one. I'm here going to do it with console. In reality, of course, this will be emails that are going to be sent out and answers that are going to be parsed. And this is going to output the candidate answer. Now, how do we know when we're done? That's where we're going to use another AI service. But again, you don't need such a strong model. So this is really feasible with a small local model to say, this decision reached service will just say, given the proposal and the candidate answer, are we done, true or false? It gives a Boolean back. Okay, let's run this. And so, I mean, this will be by email in theory, but my model, and I have some logs in here too. My model says, would you be available next Monday at 9 a.m.? And I say, sorry, that doesn't work. Okay, these are logs here. So the interaction so far was, would you be available? Invitee, sorry, doesn't work. You must answer strictly in the following format. That is this scorer, like a are we done scorer, and it says false. We're not done because it doesn't work for me. So the model is going to try again. Would you be available then next Tuesday at 9 a.m.? And I'm going to say, yeah, that will work. And then this time the model says true, it's done. And what we output in this case is, would you be available next Tuesday at 9 a.m.? And yeah, that will work, which is going to serve as an input for the next agent to book the meeting for everybody involved, including the candidates and the people that are going to interview. Okay, so this is the demo version. In the real version, you'll have to add this calendar and email support with it. Now, if that works for you, you'll have, that was the demo, already did it. Also, yeah, that's, again, you can do much better than what I made there. with some more time. So once you have this hardest part built, you can start to estimate, like, is my project gonna work, or is this like hopeless? And say when we test this module, 90% of the times it behaves correctly, and say 1% of the times it's really a bad failure, that it's gonna send something about our reviews to the candidates who could then sue us or something. So once you know that, you're gonna be able to fix things and also see if then your whole flow consists of parts like that, how much chances are there that it's gonna actually work properly. And for example, if you just have a sequence of things that all have a 90% chance to succeed, your total thing only succeeds with 65% of the time. So that's very important to just not be blind for when you set these things up. And then you can remediate. A bit later we will do that, like how do we put more controls in place so that it does not so dramatically bad outcome. Next thing is to define for each agent their inputs and outputs and tools, so you prepare to build the system. For example, the manager review part, this person does not need to update any state, in my case, doesn't need any tools and doesn't need RAG. It's gonna just read the job description, the candidate CV, the notes of the phone interview from HR, and then it will output a review object with a score, and typically rather send that by the human for validation, for verification. And so you can do that for every part of this workflow, and then you start to know how you have to build your agentic system. Then very, very important, and I mean, it's a lot of work, but you can solve a lot of things by making the thing resilient, and handling errors well, and by putting many checks in place between all the steps. So just know that you can, as I showed before, use user permissions when it comes to RAG, like getting document information, use your user permissions, so you don't output anything they could not use in the first place. And the same with tools, not every user is allowed to call any tool. Then there's guardrails, which come in LangChain4j. They look like this, basically. On an AI service, you add an input guardrail in this case, that's gonna check whatever input comes before sending it to your model. And this one is for my AI. Drug researcher that we will show later, and it just wanna check that nobody's trying to buy the biological weapon with this agent. Now, it's a bit silly, you wanna have proper guardrails, but the way this works is that whenever a user input comes, it will ask an AI service, is this an attempt to build a bioweapon, like create a toxin or something for humans? And then if the result is higher than 0.7, you're just gonna flag the user, break off the system. And then how do you know if this is an attempt to a bioweapon? You can either do deterministic things, like we don't want these and these and these keywords, these and these users, these and these countries, whatever, or you can use another LLM, give it examples. And that works pretty well, giving examples of what known antibodies are toxic to humans. That's not something we will want to assist with our drug researcher, so that's going to be flagged. But what's the meaning of life? It's not going to be flagged. Again, this is not 100% guarantee, right? You can help yourself a bit with this. If you want 100% guarantees, also you will need deterministic guardrails. You can also set guardrails on the output. If you are a car vendor, say BMW, and all of a sudden it says something about Audi, because Audi is better in whatever the user asked about, then you maybe want to intercept that with your guardrails and do a retry. Intermediary checks, retries, or escalations to humans, please build them in. And that's the thing, you can always escalate to human, typically, like the person that would normally do this step in the process. That allows you to have at least AI help your users in many cases. If you worked with types, you get way less LLM rubbish out of there, because if you ask, as you saw before, I wanted a Boolean back, it's like true or false, that's it. I don't risk that my LLM will output like, the user is not entirely sure, but this might work if you insist again. And then if your system is not designed to deal with these strings, then that's where it's gonna break. So I said, like, I want a Boolean back, and I don't have to deal with that problem already. Yeah, and it's like, be smart about your design. I'm going to skip this one. Then it's not there yet, but we're going to make it happen in the coming months. That's we already have async agents, so they will run in parallel or they will continue running as long as their input parameters are available. So that speeds up the process a bit. That we have. We have a certain form of persistence of the agentic scope, kind of the memory of our agentic system. But what we don't have yet is a persistence of the state of your flow, which I would love to have, because then if you need to book a meeting with your customer and they only read their emails a day later, you just store that state in the database, and whenever they come back, you just can continue. Yeah, crash recovery. I'm going to try to make examples of that. They're not there yet, they're coming. And I also like the idea of task buffers. So if HR has to review or make their phone calls or whatever, put them in a buffer within their tasks, and then they will do them maybe once a day. And then all the rest of your system can continue until it hits another place where a human is needed, and then send it to their task buffer. There we skipped one. Okay, then non-deterministic testing. So the nice thing about this agentic system I find is that you can test agent per agent, and since they're small scoped, it becomes so much easier to see what goes wrong or what works well than when you have one agent like do everything. And then you're going to test at the end, did it do everything, kind of. Here it's really like, okay, do we have a review that has the right format, that has a score? Like, are these things there? So it's just much nicer to work with and much more under control. We have in the Quarkus extension for LangChain4j, we have a non-deterministic tests framework that we are going to port to vanilla LangChain4j too, so it becomes available also for non-Quarkus users. The way they do it, if you test something non-deterministic, it's not pass or fail, as we are used to. It's kind of passes 95% of the time, or like, oh, critical failure sometimes. These are the things you want to know. So what Quarkus test framework does is it's gonna concurrently run as many tests as you want on different threads. And then you have typically like your golden data set, an input and a desired output that's in the sample file described below. And then you run that, in this case, 5 times. And you will use a semantic similarity strategy, for example, to see what came out of your test, how close is it to what we wanted, the expected output. Here they use these vector embeddings for it. It's one way you can check if certain keywords are present. They also have an AI scorer, which is really a full-blown LLM that's going to say, like, yeah, score how well this question is answered now. Okay, and that gives you then a score, like when it's good enough, it passes, and then maybe 4 times out of 5 it was good enough, and you start to get an ID. Yeah, it's easier to do typed testing, right? If the thing is true or false, it's extremely easy to test. If your string has to kind of have the correct words or mean the right thing, it's much slower to test. So I'm really a huge fan of typing in these agentic systems. And for your agents and tools, you just test that they invoke the right tools in the right order, and you check that they are invoked with the right input and output parameters. They test if you put extra LLMs in the tests, or if you test parts that have LLMs, it's costly, so don't run it on every pull request or like 3 times a day. Just think when you want to run which tests, because it costs you tokens. I have to start the demo. Just thinking if we have time enough, but yes, let's try. Good, this takes a bit to start. Right, last thing, we have observability built in LangChain4j, at least in the Quarkus version, and in the Spring version, we're gonna make sure that it comes fast. PR is there. Yeah, so some things like, you have things like model drift. You can solve this by using model snapshots. As you can see, if you use GPT-4 and then this date snapshot, you're making sure that you're always calling the same model, because if you just say GPT-4o, OpenAI is like every couple of months secretly behind your back going to change what happens, and that has real impacts. Say, you've been testing this with a model and it was super verbose and you said, hey, be concise in your prompt. And all of a sudden they change the model and it's much conciser. And all of a sudden your hey, be concise makes it way too short, and it's not anymore what you expect. That's a real thing, so be careful. If you are allowed to collect how people use the data, review a couple of things by hand, see what goes wrong. If they thumbs down, that's really gold. And you can even leverage AI to just group issues and to see what you need to address most urgently. Good. I'm going to quickly show off a demo, even though my time is up. I would say if you're not interested, you are very free to leave the room. I'm just going to quickly run through the AI drug researcher to show you how an agentic system can work when you put it in a state machine and have much more control. It's actually, I find it pretty impressive. I built this together with Mohammed Aid Abderrahman, so kudos to him as well. And you find this at my GitHub repo, Liseras, AI drug discovery, if you want to check what tricks I use for all the parts. Should be up. So let's go to localhost. Yes. So yeah, wait. We have even Zoom. OK, here is my chat. So I want to solve some type of cancer that's not been solved yet, and that's deadly. It's a demo thing. There's many things behind the scenes that are just demo or even outputting random things, but you can actually plug in real parts of a drug research flow and make this very powerful. So, OK, it's once pancreatic cancer, but I have actually prepared all the input articles for this with glioblastoma, which is a brain tumor. So I'm just going to say that it has to do that. What we've seen in the logs is that it has stored my disease name because I said JBM. And once it does that, automatically my state is triggered to the next thing, which is going to start to find the antigen, the marker of this disease, because that's the one we want to find and attack, basically. And it found it in a database. This is the real sequence. And then you see blue is tool calling, green is that it goes look into RAG, into scientific articles. So half of this is working properly, half this is just demo stuff. So it's searching the literature for anything that's already known that targets this disease marker, basically. And I have a null pointer exception. That's very painful. OK, then now that's good. Then you guys can go home. But no, it goes a couple of steps further. But as you can see, what I output here, it's not a real chat. This is basically informing the user of fixed things. These are tool call outputs that are deterministic. I can say with very much confidence that this is the antigen and that this is its sequence, and so on and so on. What's more in there, if you want to have a look and try it out. So proper error handling is not in there. But what's also in there is that there's other models being called. It's calling Google's AlphaFold to then output also the structure of the disease, which we return in there. It has audio. It has a lot of interesting things, so if you want to play around at home. But I'm going to let you go home now. If you have more questions, I would say come see me because time is up, or write me on LinkedIn, or if it's about LangChain4j itself, open a discussion, or even open a PR. Thank you very much.